going to work on lesson 40, which is simplifying radical expressions. Okay, every time you see the word radical, what that means is some kind of root, whether it's a square root or a cubed root or a fourth root or a 72nd root. Okay, it doesn't matter. Whenever you see that square root sign, that's what it's talking about. Now, one of your options for doing this always is to just type it in your calculator. This first one, we've got the cubed root of negative 0.008. Well, if you type that in your calculator, what that gives you is a negative 0.2. Well, how is that the case? Well, what happens here is whenever we have a cubed root here, that is saying we need three numbers that are exactly the same that will give us that number under our square root or our cubed root sign there. Alright, well if we multiply these three out, we do end up with negative 0.008. Alright, so the cubed root of this thing would end up being that there. Alright, now say you don't have a calculator, or say you're not allowed to use a calculator on this problem. Alright, say we come over to this one here, the cubed root of negative 27 over 64. Well, one of the very first things you can do with this one is we can split up this cubed root sign. We can go the cubed root of negative 27 over the cubed root of 64. Well, what is the cubed root of negative 27? That is a negative 3. What's the cubed root of 64? Is a 4. And there would be our answer. Alright, say we come to this next one. What's the fourth root of 16? Now, that one we don't use very often, so we need to come up with a game plan to be able to do this. And you can do this for every single one of these roots, whether it's a square root, a cubed root, whatever it is. You can do it for every single one of them. You can do a factor tree here. What gives us 16? Well, 4 and 4. What gives us 4? 2 and 2, and this 4 is 2 and 2. Now, you want to break down these factor trees until you get all the way down to all prime numbers here. And then, what we're looking for is we're looking for the fourth root, so we're looking for four numbers that are exactly the same. Well, I've got 4 2's here. So I'm going to circle all 4 of those 2's. And what you can do with that, when you have 4 of them that are exactly the same, one of them comes out. So that would end up being a 2 there. Alright, in just a second, I will show you what happens if you don't have stuff that goes into that circle, what we do with it. With this fourth root of 625, we can do the same thing. Alright, 625 is 25 times 25. This breaks down to 5 and 5, 5 and 5. We're looking for the fourth root, so we need 4 of them that are exactly the same. There's 4 5's, so our answer is 5. Realize that we're only taking one of them out of that though. So our answer for this one is just a 5. It's not a 25, it's not multiplying all 4 of those together, it's just one of them. Alright, now we get a little bit more complicated. We've got square root of 3 times square root of 6. Well, when both of them are under the same square root sign, one thing that we can do is we can multiply them together. So this thing turns into the square root of 3 times 6 is 18. And then we can do the same thing we did on the last page. 18 is 9 and 2, and then this 9 can be broken down as 3 and 3. Now we're looking for a square root here, so then we're only looking for pairs of 2. Well, I've got a pair of 3's here. So one of these 3's is going to come to the outside. This 2 is left over though. What do we do with that? Whatever is not circled goes back under the square root sign. So, square root of 3 times square root of 6 does equal square root of 18, simplifies down to 3 square roots of 2. Let's come down here to the square root of 176, doing the same thing. See, that one looks a little bit more complicated. We could just take a 2 out, we know that for sure. And then this is, looks like it's 88. Okay, this 2 is prime, so we can leave that. 88 is 8 and 11. 8 is 4 and 2. 4 is 2 and 2. So what we've got is we've got 4 2's and an 11. Those are all prime. Okay, so now what we're looking for is we're looking for pairs. Well, I've got a pair of 2's here and a pair of 2's there. So I'm going to take one of both of them out and put it out in front. And then the 11 is left over, that goes back under the square root sign. Now notice with these two 2's, what we've got to do with those is we've got to multiply those together. So we get 4 square roots of 11. Next one, cubed root of 750. We can do the exact same thing. Alright, first thing I see is 750 is 10 and 75. 10 is 2 and 5. 75 is, let's see, 25 and 3. And then 25 is 5 and 5. Now this is a cubed root now, so we need to look for pairs of 3 here. Well, I've got 3 5's right there. So I can take one of those 5's out, and then all the other stuff goes under my cubed root sign. Make sure you write down that 3 there, that's a very important part. What I have left over is I have a 2 and a 3, multiply those together, and I get a 6. Now what you could do to check this, just to make sure you have it right, you could type in your calculator the cubed root of 750 and you could get a decimal equivalent of whatever that is. And then you could check, well, what is 5 times the cubed root of 6? And if it's the exact same number, then you know you have the right answer. Alright. Next one. This one we could do 2 different ways. Okay, the very first thing that I see here is I see cubed root of 27. Cubed root of 27 is 3. And then this can't be broken down, so I just write this behind it. Okay, so it's 3 times the cubed root of 2. Now not everybody's going to see that, so what do? Well, we could do the same thing here as we did up here. We could multiply those together. So cubed root of 54, and then we break these down. 54 is, let's see, 9 and 6. 9 is 3 and 3. 6 is 3 and 2. We're looking for cubed root, so groups of 3. There's my group of 3. So I bring the 3 out front, and then the 2 goes back underneath. Both ways work, which tells us also that that has to be our right answer. Now, what do we do with this? We can do it with polynomials also. All right, the square root of 2x squared plus 12x plus 18. Well, what jumps out to me with this one first is this looks like it's trying to be factored. Let's see what happens when we factor it. We can pull out a 2, and we're left with x squared plus 6x plus 9. Then this thing, and remember the square root is all the way around it, this thing can be factored down to x plus 3 and x plus 3. Now remember, when we have this square root, what we did with factor trees was, anytime that we had 2 of one, we could pull one of them out. Well, we have 2 of these x plus 3's, so we can pull one of them out in front, and then we can put the square root of 2 behind it. Alright, do make sure that you put parentheses around this x plus 3. If you wrote this down like this would read as x plus 3 square roots of 2. This reads something completely different. This reads x plus 3, that whole quantity, times the square root of 2. Down here, just the 3 is being multiplied by the square root of 2, so we don't want to do this. We want to put the parentheses around x plus 3. The next one, we have the cubed root of a plus b to the 4th. So what that means is we have 4 of the same thing. Alright, so if you wanted to, you could write these out. There's my 4 of them. I need 3 of the same thing to pull it out. Well, those 3 are the same. I could pull this out in front. Once again, parentheses around it. And then this other one goes back under our cubed root sign. Alright, have to put the parentheses around those just to make sure it's read properly. Alright, but here, that's what you're doing. You're doing the same concept. If you're looking for a cubed root, you gotta have 3 of the same to be able to pull one out. Next one, we can also add and subtract these. Now, adding and subtracting, the very first thing, it's kind of like adding and subtracting fractions. You have to have common denominators to add fractions. Well, we don't have denominators in these, but we can add and subtract them if the square roots are the same, or the cubed roots are the same. So, first thing I see here is 80 and 45. Those aren't the same. So, we've got to break these down and see if we can make them the same. Not always are we going to be able to make them the same, but we at least got to try. And just like with a fraction, your very last step for each one of these is you've got to make sure that the square root is completely broken down. So, break down 80. 8 and 10. 4 and 2. 2 and 2. 10 is 2 and 5. Okay, so I've got a pair of 2s, a pair of 2s, and a 5. So this would be 4 times 8 is 32. Square roots of 5 for this first one. Once again, you could throw both of these in your calculator. 8 times the square root of 80 and 32 times the square root of 5. You'll get the same answer, the decimal equivalent answer. So then you know that they are the same number. Next one, 45, is 9 and 5, and then 3 and 3. There's a pair of 3's, so this 3 can come out with the 12. So we've got minus 36. The 5 goes back underneath. Now these square roots of 5 are the same. These now act like, say it was 32x minus 36x. These square root of 5's act just like your x's. So what we do is we go 32 minus 36 is negative 4 times the square root of 5. We bring that square root of 5 with along for the ride there. Okay, come down to 8 square roots of 32 plus square root of 2. Okay, right now they're not the same, but they might be. So we've got to go, let's see, 8 and 4, 4 and 2, 2 and 2, 4 is 2 and 2. We're looking for pairs again, so there's a pair with the 2 left over. 8 times 2 times 2 is 32. This one's already broken down, so square root of 2 gives us 33 square roots of 2. There's our answer. Next one, we can do the same thing for cubed roots. Alright, cubed root of 32, well, that is, let's see, 8 and 4, 4 and 2, 2 and 2, 4 is 2 and 2. We're looking for groups of 3. So here's a group of 3. We can pull that out. We have 2 2's left over. We don't have 3 of them, so they both gotta go back underneath the root sign. So we would put a 4 underneath. This 2 comes out with the 5, so we've got 10. 108. Let's see. 3 goes into there 36 times. 36 is 3 and 12. 12 is 3 and 4. 4 is 2 and 2. There's my group of 3. So that can come out, the 2's go back underneath. Okay, so we're going to take 3 times 2 is 6. So our answer here, these are both the same now, so 10 minus 4 is 4 times the cubed root of 4. Alright, we can do the exact same thing even if they're variables here. It's got to be the exact same underneath though to be able to add them. Alright, so we've got to break these down. 625 is 25 and 25. 25 is 5 and 5. 5 and 5. So there's a group of 3. So 5 goes out in front. I'm going to leave a little space here. And the 5 goes back underneath. For our 8 of the 5th, we need 3 of them. We have 5 of them. So if you wanted to write them out, you could. You don't have to, but it's up to you. There's 3 of them, so 1 of them comes out. These 2 go back underneath. So that's what that turns into. Plus, then this one. Alright, we'll leave the negative alone for now. But this 40. 40 is 8 and 5. 8 is 2 and 4. And 2 and 2. Now, we do see that we've got 3 2's here. Couldn't we also, now, say we go back and deal with that negative sign. Couldn't we also say that negative 8 times 5 is negative 40? And then couldn't we say that all of these are also negative? Negative 2 times negative 2 times negative 2 does give us negative 8. So we can pull out a negative 2 here for this problem. The 5 is by itself, so it goes back underneath. And then we've only got 2 A's here, so they're also going to go back underneath. Now if we look here, we've got, and then I forgot, we've got this A out in front yet, so that A needs to go in there. So then we've got our cubed roots are exactly the same. That means that we can actually subtract these. 5A minus 2A gives us a 3A times the cubed root of 5A squared. And that is our answer here. Alright, these take a lot of work. Break them down factor tree wise. It helps a lot to be able to do that. Any questions, please let me know.